This video on probability is a solution video for T&T4, page 193, question 21. In part 1 of the question, we want to find the probability of rolling a total of 7 when tossing a pair of dice. And the best way to calculate this probability is by drawing a two-way table. So do that now, pause the video, and then play and see if you have it correct. So your two-way table should look like this, and then of course the probability of getting a total of 7 is the favourable outcomes over the total possible outcomes, and in this case there are 6 favourable outcomes out of 36 possible outcomes. So this gives us a probability of 6 over 36, which you can cancel down to 1 over 36. It's useful to note at this stage that the probability of E complement is equal to 1 minus the probability of E. So the probability of E complement just stands for the probability of the event not happening. So the chances that something doesn't happen is 1 minus the probability that it does happen. And this will be useful in part 2 of the question, where we'll be looking at situations where we roll 7s or don't roll 7s. So let's just note that the probability of getting a 7 is 1 in 6, and the probability of not getting 7 is simply 1 minus 1 over 6, which is 5 over 6. And knowing this sets us up well then for part 2. In part 2 of the question, we want to roll our pairs of dice 4 times and find the probability that we get at least 2 7s. So it's important to really understand what they mean, first of all, by at least 2 7s. And really this means that we need to get 2 7s or more. So that could be 2 7s or 3 7s or 4 7s. Note that or means addition in the context of probability. So this seems like it could potentially be quite a complicated calculation, but fortunately we've got our secret weapon, which is the tree diagram. And I have to say, tree diagrams are so useful across the board in probability. If you get stuck, they're often a good way to deal with a really difficult question. So let's see how we can use it to help in this case. The first thing I'll need to do is set it up. Now I'm going to have 4 rolls for my dice, so I need to have a column for each of those, then a column for outcomes and a column for probability. Okay, so I'm set up and ready to go. So I'm going to roll my 2 dice to begin with for roll 1, and of course my outcomes could be 7 or not 7. And in the interests of being concise, I'm going to call those 7 for rolling a 7 and N for not rolling a 7. Then on to roll 2. And again, in each case, we'll have 7 and not 7, or N. On to roll 3. And you can see that the amount of information in the column is doubling each time, so I really have to be careful with my spacing. And there's my last roll, and again, 7 or N. And you can really see here how neatness is as much a factor in this question as anything else. So now I've got all my different outcomes written in for each of my first 4 columns, but I also want to make a note of my probabilities. And we noted earlier that the probability of getting 7 is 1/6 and not getting 7 is 5/6. So now we'll just fill those in if we have space. So I've fitted them all in there, and now I'm going to list out my outcomes. So for example, my first outcome there is 7, 7, 7, 7. If I got 7 on all 4 rolls, just following that first path, and then I'll continue following each possible path until I work my way down through all the outcomes. And just be careful that you don't leave anyone out by accident, maybe just because it isn't quite as neat as it should be. And also bear in mind that you can quite easily check to see how many outcomes you should have fully listed at the end, because we've got 2 outcomes, and that's doubled 4, doubles to 8, doubles to 16. So I should have 16 outcomes in this final list. So I'm just pausing here halfway through my list. So I've gotten as far as this N, and now I'm moving on to this branch here. So N, 7, 7, 7. So now I finally have my 16 different entries, and now I can work out my probabilities. My first one of 1 over 1296 is got by multiplying 1/6 by 1/6 by 1/6 by 1/6. And my next one then, my 777N, is 1/6 by 1/6 by 1/6 by 5/6. And just be very careful as you go down along through those, calculating them. But actually, you could be a little bit clever about it, because if you look at it, each 7 in your list in your outcome is a 1/6, and each N is a 5/6. So you should be able to actually work it out from this list too, without getting too bogged down in the previous 4 columns. So pause the video here while you work those out, and don't forget, when you have your final probabilities, they should total up to 1, and if they do, then you know that you're on the right track. So that's my full list of probabilities there. And then finally, I'll just add them up to just double check that I get 1, and I do get that total, so I'm happy that I'm on the right track. And now I want to use this to work out the answer to my question. So just to remind ourselves again, the probability that 4 rolls give at least 2 7s. So I want 2 7s, or 3 7s, or 4 7s. So I can actually go down through my list of outcomes now and select the ones that fit that description. So I'll pick out all the ones that have 2 7s first of all, and then I'll pick out the ones that have 3 7s, and then finally the ones that have 4 7s. And there's just one of those. And then I'm going to take the relevant probability for each of those, and then add them all together. And when I do that, I find that my answer, the probability of getting at least 2 7s on those 4 rows, is 171 over 1296.